Welcome back to the second question related to Pythagoras Theorem in our series, Geometry Step by Step. Question 2. Find the length of the unknown sides in the given triangles. Find the distance of the hypotenuse from the opposite vertex. Find theta in each case. There are 3 different things we need to solve. Let's advance step by step. First, we can use Pythagoras Theorem to find the length of the unknown sides. Remember, a squared plus b squared equals to c squared, and c is the hypotenuse. In the first triangle, the unknown side x is the hypotenuse because it is directly opposite the right angle, which is indicated by the square shape. Also, side x is the longest of the sides, as we will soon see. Instead of a to the second power, we write 8 to the second power, and we replace b with 10. In the place of c squared, we write x squared because it is the hypotenuse. 8 to the second power, that is 8 multiplied by 8, is 64. 10 to the second power is 100 because 10 times 10 is 100. The sum of 64 and 100 is 164. In order to find out how much x squared is, we need to take the square root from both sides of the equation. Most calculators have the square root function. If you have a scientific calculator, such as Texas Instruments, you can take the square root by pressing second and then the x to the second power button if there is a square root sign above it. Type in 164 and hit enter. In this case, 2 decimal places is sufficient, so we round up the answer to x equals to 12.81. The second triangle has an unknown side, y, but this time it is not the hypotenuse. This is very important. If we do not realize this, we will write the equation wrongly. Let's replace a to the second power with the shortest side, y to the second power. Instead of b to the second power, we write 14 to the second power. The value of the hypotenuse, which in this case is 16, is written in place of c. Remember that the square of the hypotenuse equals to the squares of the other 2 sides. This is why you must pay special attention to the hypotenuse, whether it is the unknown side or not. We start again by calculating the squares. 14 to the second power is 196. The square of 16 is 256. Now look at the equation. We have y to the second power plus 196 equals to 256. We want to find out how much y to the second power is, so we have to remove 196 from the equation. To maintain both sides as equal, we must subtract 196 from both sides of the equation. Therefore, y to the second power equals to 256 minus 196. Calculate them together and you get 60. Now, we again have to take the square root of both sides in order to find out how much y equals to. The square root of 60 is approximately 7.75 when we round it up to 2 decimal places. For the third triangle, the process is the same. The unknown side, z, is not the hypotenuse in this case either, so we write the equation as z squared plus 24 squared equals to the hypotenuse squared, which is 25 squared. 24 to the second power is 576, and 25 squared equals to 625. Again, we want z to the second power to be alone on this side of the equation so that we can know how much it is. We subtract 576 from both sides of the equation. As a result, z squared equals to 625 minus 576, and this equals to 49. To find out the value of z, we need to take the square root of both sides of the equation. You can again use your calculator. The square root of 49 is 7. Therefore, z equals to 7. The first part of this assignment is now completed. Next, we are asked to find the distance of the hypotenuse from the opposite vertex. To solve this, we need to understand the concept of similar triangles. Until then, God bless and farewell.